Okay, so here we are with part 2 of exam 3, and in this part we are going to derive an explicit or forward differencing scheme for calculating the time varying temperature profile. And we start off by using our uniaxial time dependent heat diffusion equation. Got that one solid, I think, now. So we can start off by taking the left hand side of the equation and manipulating the derivative with respect to time just a little bit. So what that is going to turn into is we are going to get T, and that's going to be at some position j with some time increment n plus 1. And then this is going to be subtracted from our same temperature, the T, at the same position j, but at an earlier time of just n. And then finally, this is all going to be over delta T. Sorry about that interruption. Roommate was knocking on the door. So now, since we've already manipulated the left-hand side, obviously we have to do the right-hand side now. So we can start that off by, the right-hand side here. And obviously they'd still be equal to each other. So we are able to do that similar as the last one. So we will have our temperature, or some temperature at, this one's different. It's at position j plus I. And then our time here is just n. And then it's going to be subtracted, similar to the last part, from our t, our time at position j, and at time n. Or I'm sorry, t is temperature. I don't know why I've been calling the big T time. And then this is going to be over delta t, or I'm sorry, delta x. Because the right-hand side has x, not t. Don't know why I said that. And this difference, this difference is going to be subtracted from another temperature at time n, position j, and this is going to be subtracted from same temperature, same time, but the position is just going to be a little bit ahead, so it'll be j minus 1. Fix that j up a little bit, and this is also going to be over our delta x. And then lastly, this is all going to be over another delta x. Ooh, let's redo that one. Something doesn't seem right. Oh, I forgot the alpha. And then obviously we still have the alpha out in front. So now that we have our finite difference approximations equal to each other, we are going to be looking for the Tn plus 1, or T at time n plus 1 at position j, and we are going to add it over to this part right here, and we are going to add it over to the other side since we are trying to get this part alone, and we will also be multiplying by delta t. Okay, so now time to add this over and multiply this over because we just want the t n plus 1 j all by itself. So we can go ahead and we're going to rewrite this. And now it is going to be equal to delta t. I'm bringing our delta t over, multiplying that. So you got to do that first before you add the tjn over. And that's going to be multiplied by, our t at time n at j plus 1. Ooh, jeez, let me redo that. J plus 1, and then this is going to be subtracted from 2 tjn because you can see we have 2 of them right here, both negatives. So we have our 2 t at time n, point j, and then finally this is going to be subtracted from our tn of j minus 1. And then obviously we have to add the tjn over. So we'll have plus t and j. And then this is going to be over, because we just simplified this, it's going to be over delta x squared. So, getting a little bit ahead of myself, x squared. So now we're going to create a variable r. This is just going to be used to help simplify this up, make it look a little better, a little bit cleaner. And for our r, that is going to be equal to our delta t times our alpha. And that's going to be then divided by our delta x squared. So now we can go ahead and take this r and plug it into here, and that will allow us to get our final explicit differencing scheme. So we have our t n plus 1 j. Obviously that stays the same since that's what we were trying to keep constant. And then that is going to be multiplied by, or I'm sorry, it's going to be set equal to Tn of j, and then multiplied by our new variable r. And then we are just going to keep the exact same stuff right here in the parentheses. So finally, it's being multiplied by t of n j plus 1 minus 2 of just normal tnj's. And then finally, that is subtracted from our tn of j minus 1. Terrible. So there we go. That wraps up part 2, and I will see you for coding in part 3.